Okay, number 9. We've isolated the radical, so that's good. So we need to get rid of it by simply coming in and squaring. But if we square the left, we got to square the right. This right is an x plus 5. You got to square the whole thing, which means you got to do a binomial of x plus 5 times the other binomial x plus 5. So right here, we'll get 2x plus 13. Nice and simple. When you square a square root, boom, disappears. That's how we get rid of square roots. But now I got to do an x plus 5 times an x plus 5. So a lot of us probably already know the answer to what that is, the trinomial, but let's just do what we need to do. We'll shake hands here. Each piece will get distributed through x times x squared. X times that 5, 5x. Now this 5 must get distributed through, which gives me another 5x. And then 5 times 5 is 25. So this equals, putting it together, an x squared. 5x plus 5x is what? 10x's plus the number 25. Now, at this point, whenever you have a trinomial, you want to get it set equal to 0. That's always our goal for the most part, especially with the problems we're doing here. Okay? There's other ways, but we don't know how to do things. So this is what we're going to do. We're going to get it set equal to 0. So we're going to simply subtract 2x to move it over. And then we're going to subtract 13 and subtract 13 to move it over. So what do we now end up having? We have 0 equals x squared. Gain 10, lose 2, you've gained 8. And then gain 25, lose 13, you're now ahead by 12. We now have a trinomial equaling 0. Now, we could apply the quadratic formula here, okay? But this guy's going to factor, and you and I don't know the quadratic formula right now. We don't know it very well if we do know it. So we're going to simply write down the factors of 12. 1 times 12. We're going to factor this. 2 times 6, 3 times 4. And we need them to give us an 8. That's obviously our 2 and 6. So this breaks down to an x plus 2 times an x plus 6. It factors nicely. Now, we have two things multiplied together that equal 0. That means one of those two pieces has to be a 0. That's the only way you could have it. 0 times something would give you 0, or something times 0. You can't have ones and negatives. It won't give you a 0. So either this guy has to be 0 or that guy has to be 0. So let's do that. X plus 2 has to be 0, or the x plus 6 has to be 0. I subtract 2 from both sides. I get negative 2. I subtract 6. Negative 6 is my other option. Negative 6. Sorry about that. Now, it might be they both work. It might be that only one of them works. Let's see. We have to plug them in. One of them could be an extraneous solution. I'm going to start. Let's go back, and we're going to erase all this in here. And we're going to plug in our values and see into the original equation. We're going to plug in negative 2 and negative 6 and see who works. I think only one of them will. Because remember, if you graphed this, it would be like that. More than likely, you have the line x plus 5 coming through hitting at one point. But it could come through and sort of hitting 2. We don't know. We're going to find out. Let's plug in negative 2. 2 times negative 2 plus 13. That was a negative 2. That's negative 4. Negative 4 plus 13 is what? 9. So this is the square root of 9, which is 3. Over here, when we plug negative 2 in, negative 2 plus 5 is what? 3. Negative 2 works. Awesome. Negative 2 is one of our solutions. But we now need to see, does negative 6 work? Maybe it does, maybe it doesn't. Let's find out. 2 times negative 6 plus 13. 2 times negative 6 is negative 12. Negative 12 plus 13 is 1. Square root of 1 is 1. But when you plug negative 6 into this x and get 5, you get negative 1. 1 doesn't equal negative 1. So this is an extraneous solution. So the only solution to the problem is x equals negative 2.